question states, use oxidation numbers to decide whether each of the following is a redox reaction or not. And they give us a list of list of reactions. Now, the thing is, one could be a redox, two could be a redox, all three of them could be a redox, or none could be a redox. So let's find out which ones are a redox and which ones are not. So if you guys remember, what I like to do is I like to read, reread, write down what I'm given and what I need to find. So we are just given the reactions, so I'm just going to put down we need to find redox reactions. Okay? And for this video, what I'm going to do is I'm going to do each of the reactions individually, one at a time. And we're going to use the oxidation rules we learned in the preview question, or preview video, to understand what's going to happen and how we're going to solve this. So let's start with the first one. Okay, so I'm given a reaction here where I have calcium oxide plus carbon dioxide gives me calcium carbonate. Now, one thing I like to do, guys, when I'm solving redox is I first like to identify, do I have any, either any elements in elemental form or any polyatomic ions? Well, I don't have anything in elemental form right now, but I do have a polyatomic ion, which is carbonate. And I'll just put down on the little sidelines, carbonate is -2. Now I'll write that down a little bit farther. So I'll just put down here as a little side note, carbonate has a -2 charge. I'm just going to remember that for right now. Then what I like to do, guys, is I like to then create three kind of like rows almost. So I kind of like to do kind of like this, or two rows, where the first row is the charge of the individual atom, and then the bottom row is the individual is the charge for all the atoms combined of the same element for the same compound. For example, for carbon dioxide, I will put, okay, I know that oxygen has a -2 charge, and then I would say in this column I have 2 oxygen atoms for carbon dioxide, so I'm going to put down a -4 because 2 times -2 is -4. And this helps me, guys, because then I can solve for the unknown charges of other elements, like in this case carbon. So I know, okay, because the fact that it's a compound, it has a 0 charge. So I have to get to 0 somehow. If I have a -4 charge right now, that means that carbon must have a +4 charge. So I'll put that up here. That's how I like to do it. You can do it your own way, but for me, I find this very effective because it helps me organize what I'm trying to find, and also helps me lay out like what I like to call a battle plan. So anyway, let's do it now for calcium oxide. So I have, once again, a -2 charge, and since I only have one, I don't need to write it down here, but I will. So it's a -2 charge. So that means it's just a +2 charge for calcium. And also, if you remember, group 2 and group 1 metals always have a +2 or +1 charge respectively. So let's go over here now. Now, the reason I did put down the realization that this is a polyatomic ion is because of the fact of 2 reasons. One, I realized that, hey, look, if there's a 0 here, and this is a compound, and if this already has a -2 charge, then the metal ion, or calcium, always has to have a +2 charge. Now, in this case, it was easy because we also know that group 2 metal ions have a +2 charge. But in general, it also helps you understand polyatomic ions can also give you shortcuts to finding out the charges of unknown atoms or ions. So anyway, let's just wrap this one up. So it's -2 because it's an oxygen. There's 3 oxygens, so that's -6. And since I want to get a -2 charge, I need to realize that I have a +4 carbon, because 4 plus -6 is -2. So if we compare all the numbers for all the atoms, or all the ions, all of the charges have stayed the same for each one, and none of them have changed. So this is not a redox reaction. So let's try the next one. Here we have potassium nitrate dissociating into potassium oxide and also nitrogen gas and oxygen gas. So like I said before, guys, do I have any elemental any atoms in their elemental forms, or do I have any polyatomic ions? And in this case, I have both. I have N2, O2, and NO3. So I'll just put that down as a little reminder. And if you guys remember, N2, any element that's in their natural form, such as gas, in this case, the charge is 0. So, for instance, N2 we know is 0 then. We also know that O2 then is 0. And then I kind of like to do what I like to do, like I told you guys. I like to then set 2 rows. And then I like to put down the individual charges of each ion. So for oxygen, we have a -2. Potassium is a given because it's a group 1, so it's a +1. Potassium here is a +1, and then oxygen is -2. Then I like to move down and know how many ions I have for each compound. So I have 1 potassium, so that's still a +1. Let's label this for nitrogen as X. Also, I have for oxygen here, for the potassium nitrate, 3 oxygen, so 3 times -2 is -6. And still it's X, because NO, because there's only 1 N. Also over here, guys, I have 1, so that's -2. But I have 2 potassium, so that's a +2. And then 0 and 0 still. Now the only one we really need to solve for right now, guys, is nitrogen on the reactant side, and that's pretty easy. So we know in order to get 0, it would be +1 minus 6. So that's a -5. So in order to get 0, this has to be a +5. So, has anything changed here? And the answer is yes. So if you look here, guys, my nitrogen went from +5 to 0. And my oxygen went from -2 to 0. So, if you guys remember, when you gain electrons, you go down and you're reducing. If you lose electrons, you gain a positive charge and you go up. So, if you lose electrons, you are going up in positive charge, and if you're gaining electrons, you're going down in negative charge. So, for nitrogen, we had it where +5 on the reactant side went to 0. So this gained electrons. So this gained electrons, so this was reduced. And then for my oxygen, it went from a -2 to 0. So it lost electrons. So it was oxidized. So this is a redox reaction. So we can solve it and confirm this is a redox reaction. So let's do the last one, the last reaction together, guys, and see if it's a redox or not. So like I've said before, guys, are there any polyatomic ions here that we need to worry about? And the answer is yes, we do. We have hydrogen sulfate, we have hydroxide, and we have another sulfate. So we have a lot of polyatomic ions here. So I'll put down, just down here, HSO4 has a minus charge, OH has a minus charge, and SO4 has a -2 charge. Then what I'm going to do, guys, like I said before, I like to write the 2 rows. So, and then I put down what I know for certain are what certain charges I have. For example, sodium has a +1 because it's a group 1 metal, so it has a +1 charge. I also know that hydrogen, since it's not bound to a metal, and in this case, guys, it is not because it's a polyatomic ion. So it's bound actually to the sulfate, not to the hydrogen, not to the sodium. So it has a +1. And then I also know that oxygen has a -2 charge. +1 again for sodium. +1 for hydrogen. A -2 for oxygen. +1 for sodium. -2 for oxygen. +1 for hydrogen. -2 for oxygen. And then my sulfurs are the ones that I need to solve for. So, then like I said before, then in this column I like to then write down the charges of all the atoms combined within each compound, which per element. So for example, here for oxygen, -2 times 4, so I have 4 oxygen atoms, -2 times 4 is -8. There's only 1 sulfur atom, so it's still X. 1 hydrogen, so it's still +1. I'll put this in parentheses because we know this is a -1 charge. And then +1 for sodium because there's only 1. Here we have the same thing, +1 for sodium, only 1 sodium ion, so we have +1. We have a -2 times 1, since we only have 1 oxygen, same with hydrogen. Then over here, guys, we have 2 sodiums, so that's a +2 now. 1 sulfur still, so that's still 1x. 4 times -2 is -8. +1 times 2 is +2. 1 times -2 is -2. And then, guys, to solve for x, like I said before, I'm also going to put this in parentheses because this is also a -2, the reminder. So, in other words, guys, we realize now that we have a -1 charge here, so we got to solve for x. So +1 minus 2, +1 minus 8 has got to equal -1, so this has to be a +7. I'm sorry, a +6. Because the fact +1 plus 6 is 7, minus 8 is -1. So this is a +6. And over here, guys, same thing. X minus 8 has got to equal -2. So add 8 to both sides. So this has got to be a +6 as well. So, once again, if we look closely, we have sodium +1, +1, +1. Hydrogen +1, +1, +1. Oxygens +2, -2, -2, -2, and then sulfur +6, +6. So none of them have changed in oxidation, so this is not redox. So that means the only one that was a redox was option 2, which should be answer 2 on your sheet, and you finally have your answer.
The Teaching Center, UF's Learning Resource Center.